In this video, we're going to be looking at another example object for the SolidWorks Associate Certification exam. And so this is a pretty simple object, but it's got a few tricky parts on it. And so this is the object we'll be building. You can see that it has some global variables that we'll need to enter in and a shell cut out. And so as always, I'll have the object up here in the top right corner so you can see it throughout the drawing. And let's get started. Okay, so like I said, we have some global variables, so let's go in and enter those right now. So we'll go down to our equations, and we'll go to our global variables. We have A, and we'll tab over, and we'll see that A, in this case, is equal to 60 degrees. Keep tabbing. B is equal to 64. C is equal to 140. D is equal to 19. I'm going to add in another one because I've built this object before, and there's some parts where it's actually handy to have a value that is half of what B is. So you can see for determining like the radius up at the top and the length of that piece up at the top, having that value is useful. So we're going to make this E. And if we tab over here, we can say that this is going to be equal to 0.5 times, you got to put quotation marks around it, B. And then we can say tab. And you see it did the math for us here. It said 32, but this will update if we change these values. So then we say OK. All right, now we're going to go to our front plane, and we're going to start a new sketch. All right, so I'm going to put a reference line in because I find that the centerline references are handy to have when you're drawing if you want to do angles and things like that. So here we go. We have a center line that goes through our origin here, and we can look at our drawing and we can decide how we want where we want our origin to be. I think I'm going to pick that bottom corner where the angle starts going up to be my origin. So we'll start drawing here, and we'll start out here. We'll draw out. We'll go up. So some of these you can see that we want these lines to be vertical and horizontal for at least part of the drawing. We're going to come back, and it's going to be horizontal, but we're not going to go all the way back to that point because we have an angle going up. So we're going to click here. We're going to bring our object up at the angle. We're going to then come 90 degrees off of that. And so you can see we get these reference lines here, these yellow reference lines that kind of give us an idea. We'll come up here. We'll go straight up 90 to that. We'll come back. And we might get it to pick up a line for us. I don't see one, but we can bring it back down, and we'll snap to this line here. Okay, there we go. Now we've got our object, and we can say escape. And so a few things that we can do here that will make this a little bit easier is we can actually go in and we can make our lines that we want to be parallel to each other parallel. And that will help with some of the drawing. So to do that, we'll come in here, you can click on this line, push Control, and click on this line, and just click parallel. Same thing with these two, and same thing with these two. And so the nice thing about this is if you have two parallel lines, if we change this angle and these two lines are parallel, we'll change this angle as well. So that will help out with some of this drawing. And then we can go from there. So we have a few values here. We can click on this. We'll go to Smart Dimensions. This value is going to be equal to, we want to say equal. We say global variables. We want that's D. We'll say enter. This is also equal to our global variable of D. And this distance here is equal to D. Oh, I want to say global variable. If you just type D, it won't have the quotation marks around it, and it won't update. So there we say. Okay. So those are all updated there. Now we have this value here is equal to our global variable of C. And this value here, now this one's tricky. You want to make sure that you don't have it snap to that line. You need it to be this line right here where it's coming parallel to the surface that you're giving a value to. And this is going to be equal to 90. All right. And then we have this value up here, and this is where the first time that we use E as an option. So this line is going to be equal to 51, but then it's going to have the radius of the circle up at the top. And so what we can do, we know that radius is going to be half of B if we look at the drawing. So if we go here and click on this, and we drag this up once again, make sure that our line is parallel here. It's fighting me a little bit, but we got it. And then this is going to be equal to our global variable of E plus 51. Now we can say okay. All right. And so that gives us a value there. And then finally what we want to do is we want to go through, and we have a few other things here. We need to tell it what this angle is going to be. So from here down to this angle, or to this line, and pull off of there, and we see that that is equal to A. So equal to global variable A. Say enter and enter. And now our object is fully defined. So the next step here will be to extrude this object. Features, extrude boss base. And in this case, it doesn't matter that we if we extrude in one direction or the other. So let's just extrude it out this way, and we'll say our extrusion is going to be equal to global variable B. And we say okay. And there we go. Now we have our extruded object. All right, so this next step is actually really easy. There's you can see that we need to round this off, and so there's different ways that we could do that. We could come in here and we could draw our arc onto this surface and do an extruded cut, and it works that way. There's some trickiness to it, but there's actually a simpler way to do this. And what we can do is we can actually use the fillet command, and so we can go up here and we can say fillet. We can pick this edge right here because that's where we want the round to be on. And we can go down here and we can actually tell it that we want our fillet to be equal to our global variable of E. And you remember that that is half of this distance here. And so if we go okay, you can see that it goes there. And then if we go over to this line, we can do another fillet, and we can do the same thing. It autofills with that 32, but you want to make sure that you change that to your global variable. Because if you don't, when we update our global variables for the second part of this, you'll notice that the numbers don't work out right. And so then if we say enter and say okay, now we get a rounded off edge there. So that's pretty simple and works pretty well. So then the last part of this, what we want to do is we want to drill a hole through, and then we're going to do our shell. If we click on this surface, we can do new sketch. I'm going to go in and I'm going to put a reference line in, and I want it to reference where this edge of this fillet touches the line. Because if you look at the drawing, that's where the line is centered. It's centered at that distance. The other way you could do it is you could measure up 51 from this edge to the center point, but this will work this way as well. So we click there, and we go down and we hit the same spot down there, and then we push escape. And you can see there that we get this indicator for the midway point, which we'll use as well. All right, so let's draw our line, our circle here. So we find that midpoint, click on that, drag out, and we go to our smart dimensions. We see that that circle through there is a diameter of 19. Say enter. And you can see now that's all fully defined. So that means that you have enough referencing between these points and that center point that you don't actually have to put in your measurements here. Say okay. And we will do a features extruded cut. This is another one where you could give it a value, but since we're going to be changing the shape of everything, it's actually easier and a little bit more future-proofed to say up to surface. We'll spin around here and we'll tell it to go to that surface. Say okay. And there we go. Now we've got this part of the body. Now the final part we need to do here is we want to make this a shell. And we see on the drawing that our shell is a 3mm shell. So if we go up here and we click the shell feature, it's going to ask us what faces we want to take out. And the way this works is you select the faces that you want to cut out of your shell. First thing we want to do is we want to tell it that it's 3mm. So we have that. And now we want to go in here and we want to cut this face out, and we want to cut the inner side of this tube out. And we can say okay. And when that happens, you see that basically we have our final object here. The final thing we want to do is we want to go in and we want to change our materials to brass. And if we go over and we right click on materials and we go to edit materials, you could search here for brass. That's one quick way to do it. And it shows up right there. The other thing you could have done is, if you knew that brass is a copper alloy, you could go down to your copper alloys and choose brass. Either way works. And we'll want to cross-reference, make sure your mass density is the same as what the book is calling, or the question is calling out for. Once again, this is in kilograms per meters cubed versus grams per millimeters cubed, but the math works out that these two are the same. We click apply and click close. All right, so now our object is in brass and it's the correct shape. We can spin this around a little bit, make it look like the picture roughly, just so that you can check and make sure everything looks okay. All right, with that done, let's go up and go to our evaluate and choose our mass properties. I'm going to look at our mass properties. In our mass properties, we have our mass here in grams, and this would be the value that you would be writing down in the for the exam. If you scroll down in the PDF that I sent out, you can see there's some handwritten numbers in there. Those numbers are actually wrong. You want to scroll down to where there's actually the answer key here, and you can see that the value we came up with is correct. The next step of this question is, you can see we have question 1 and we have question 2. And this is where we can go in, and this is why using the equations is so nice, because instead of having to go in and manually change everything in the drawing, especially in cases, say like with the global variable d, where it's represented multiple times, we can go in here and we can go to our equations, right click and manage equations. We have our equations up here, and now what we can do is we can just go through and we can update these for our question 2. So this value here is going to be equal to 50. This value here is going to be equal to 70. And you can see when we did that, when we updated B, it also automatically updated E. This value here is going to be equal to 160. And this value down here is going to be equal to 23. And you can see it's rebuilding the object as we go as well. We click OK. And now all of those variables have been updated. And you can see that things were adjusted. Like our hole is still adjusted, so it's lined up with this point here. And we can go in, and we're still the same material. So we can go in with those updated features, and we can go to our evaluate and mass properties. And we have a different mass here. And it's 1,230.82 grams. In this case, once again, our the written number is wrong. But if we scroll down to our answer key, we can see that the answer is 1,230.82. And so that's the quick way, and that's the beauty of using those global variables. That's all we have for this object. And like I said, it was pretty simple. It had some tricky parts, but if you were clever about how you used your global variables, they actually went pretty quickly. If you have any questions about this, feel free to reach out to me and ask. I'll talk to you later.